Hello. Okay. That's a lot of stuff. Hi, everybody. My name is Kody Ludwig, as Aaron introduced me. I have a lot of information to go over, so I'm just going to jump right into it. So my project was called Bioaccumulation and Public Health Implications in the Tissue of the Dungeness Crab caught within the Washington coast and the Hood Canal. There we go. Okay. All right. So arsenic, mainly referred to as a heavy metal, arsenic is actually considered to share characteristics with nonmetals and metalloids. And it's also one of the most commonly found metals throughout the environment, either in the water, the soil, or the air. Although naturally found in the environment, in the marine ecosystems, it's mainly found due to introduced anthropogenic activities, such as pesticide, herbicide application, mining and smelting, wood processing, waste disposal, as well as vehicle and boat-related activities and surface water runoff. So why do we care about this heavy metal? Well, what we most know about arsenic is that in its inorganic form, it's highly toxic and can cause both carcinogenic and non-carcinogenic effects, thus leading to various cancers as well as damage to systems throughout our body, as well as to our organs. Other forms of arsenic exposure, including consuming seafood products. This can occur when marine organisms accumulate arsenic, either from the water or the sediment, and then as we consume them, the trophic transfer of these harmful accumulants can then go into us and can be harmful. However, most of the arsenic present within seafood products is actually in its organic form, known as arsenobenatine. And this is actually non-toxic to humans, and we can get rid of it easily with no health risks. However, inorganic arsenic can be present still within these marine organisms. It's just found in lower proportions. Previous literature has found that it can be between less than 1% up to 20% of the total arsenic found. So based off the variability found within these organisms, it highlights the need to investigate how much is actually in these marine organisms that we're consuming on a daily basis. So with that, I chose the Dungeness crab, Metacarcinus magister. This crustacean is iconic in that it is commercially, recreationally, and culturally important to various tribes throughout the state, as well as to the general public. This crustacean in particular can accumulate heavy metals in two edible tissues that we consume, the hepatopancreas and the muscle tissue. So you may be asking, what the heck is an hepatopancreas? Well, in a human perspective, it's the combination of the kidneys and the liver, and its main job is to detoxify foreign substances and absorb nutrients. As a result of this role, though, previous literature has found that the hepatopancreas concentrations can hold 75 to up to 95% of the total amount of heavy metals within this one tissue. Thus, there are some potential risks in consuming this tissue. So with that, this brings me to my research questions, which is there a significant difference in the concentrations of inorganic arsenic caught along with the Dungeness crab caught along the Washington coast and within the Hood Canal? As well as, are these inorganic arsenic concentrations higher in the hepatopancreas versus the muscle tissue? And the biggest question of all is, are these inorganic concentrations in the Dungeness crab from both these sampling sites above the EPA standard for healthy consumption? So with that, let me introduce you to my sampling sites. So 15 crabs were collected within the Hood Canal in the marine area 25C at shallow depths between 0 and 300 meters, as well as 20 crabs were collected along the Washington coast in the marine area 60A1 at the top there on the left. And with that, after collecting the Dungeness crab and getting them back to the lab, I then extracted out the tissues. The picture on the top right there gives you a good visualization of what the hepatopancreas actually looks like. It's that orangey yellowish material in the middle there. So then after getting the tissue samples, I then had to make them go from a solid to a liquid. And I did using an acid digestion with a combination of nitric acid and hydrogen peroxide, and then heated them up on this heating block for a very long time. I then filtered out the solid samples and then diluted them down with water. And I did this so I could analyze them using this great machine, the ICP-MES, which stands for the inductively coupled mass spectrometer. This step, including diluting the samples down even more, as well as calibrating the instrument with external standards, which consisted of various concentrations of arsenic and levels that I thought I would find within my samples. So I got arsenic concentrations. However, there was an issue. So the ICP-MS cannot differentiate between organic arsenic and inorganic arsenic. It just gives you total arsenic concentration. Thus, I used 1% of the total amount of arsenic that I found and represented it as inorganic arsenic. So then I could use these values for my health risk assessment. So I used the EPA screening value method, which includes using different parameters combined together to give you a number. The one parameter I'd like to point out is the consumption rate of the organism for selected populations. So I ran different scenarios in which I used different consumption rates that were corresponding to different subpopulations that could possibly be at risk of consuming higher amounts of inorganic arsenic due to them consuming more Dungeness crab. You'll see those exact numbers that I show you as a reference, so you know like how much Dungeness crab they're actually consuming. So let's get to the results. So I compared the muscle tissue concentrations in the Hood Canal versus the Washington coast. My hypothesis was that the Hood Canal would have significantly higher inorganic arsenic concentrations based on it being more urbanized. However, this was not the case, and the Hood Canal was not significantly higher in inorganic arsenic concentrations. So then I repeated the same test, but looked at the hepatopancreas concentrations. Once again, I compared the two sampling areas. My hypothesis was the same. The Hood Canal would be higher in inorganic arsenic concentrations. Once again, this was not correct. And the more interesting thing was the Washington coast concentrations were actually significantly higher than the Hood Canal. So I then ran a correlation analysis looking at the muscle tissue samples and the hepatopancreas tissue samples within the Hood Canal, and to see what the relationship was like between these two variables. I found a moderate positive relationship between these two variables. And then I repeated the same test, looking at the muscle tissue samples again and the hepatopancreas concentrations, but within the Washington coast. And this time I found a strong positive relationship between these two variables. So based off finding different variations between these two different sample sites, it could suggest the variability of these Dungeness crab in accumulating inorganic arsenic within the marine environment. So what we're all worried about, the health risk assessment. So this table shows you the estimated inorganic arsenic concentrations that I found within both tissue types as well as within both sample sites. And the values below that, the screening values, are the numbers that I used that incorporated all those different parameters. To the right of that also are the actual consumption rates that correspond to the various populations that could possibly be at higher risk of eating or inorganic arsenic due to them eating Dungeness crab. So if you compare the concentrations I found at the top of the chart versus the screening values at the bottom, you'll find that these concentrations are significantly lower than the EPA screening values. So what did I learn over this? So overall, I found that there was a low presence of inorganic arsenic within these Dungeness crabs from both sites. In reference to the Hood Canal, these concentrations could actually be considered at background levels from previous literature analyzing the Puget Sound. In reference to the Washington Coast, however, this study, to my knowledge, is the first that examined heavy metal contamination along the Washington coast. Second thing I found in looking at a paired t-test and comparing the hepatopancreas versus the muscle tissue concentrations, the hepatopancreas was not significantly higher in both sampling sites versus the muscle tissue, thus not following a typical pattern that I had previously found in literature. The reason behind this could be that the Dungeness crab is able to metabolically regulate inorganic arsenic out of the hepatopancreas, thus leading to lower concentrations, as well as this could possibly be the reason why I found low amounts of inorganic arsenic in either of the tissues. The third point, I found that in comparing the two sampling sites, the inorganic arsenic concentrations within the Hood Canal were not significantly higher than the Washington coast. Thus, again, not following a typical pattern that I found associated with increased anthropogenic activities. So this could suggest that the accumulation patterns that I observed were unrelated to urban influence, or that these two sampling sites actually share more in common anthropogenically wise than I had previously thought. And the biggest point of all is that these Dungeness crabs should not present a human health risk in consuming them due to the levels I found being significantly lower than the screening values. It is important to point out, though, that these EPA screening values are only partial guides to establishing safe seafood consumption. Every individual is unique and could potentially have characteristics that could make them more sensitive to harmful pollutants. As well as my inability to differentiate between inorganic arsenic and organic arsenic within using the ICP-MES, I did have to make assumptions, thus there are some levels of uncertainty. However, I actually ran extreme scenarios in which I used 20% of the total arsenic that I found as inorganic arsenic, and even during these situations, the levels were still significantly lower than the screening values that I calculated, thus adding some more confidence to the health risk assessment. So overall, I found that the Dungeness crab does have the ability to accumulate inorganic arsenic in its edible tissues. However, these are low levels of inorganic arsenic, thus presenting not a human health risk. In addition, as I previously stated, this would be the first study that examined heavy metal pollution along the Washington coast. So for future studies, we should continue the use of advanced analytical techniques to be able to differentiate organic arsenic versus inorganic arsenic in looking at seafood products we are consuming on a daily basis. As well as we should continue to explore watershed dynamics and investigating how anthropogenic activities could be resulting in heavy metal accumulation within these marine ecosystems. And overall, from this study, we should continue monitoring seafood products that we are consuming on a daily basis, as well as the continued monitoring of the environment, as well as its environmental health, as it can have negative side effects against us. So I would like to thank Erin Martin, my thesis advisor, for all of her help through this process and her constant encouragement that I could finish on time. I'd also like to thank Jenna Nelson, who helped me with all of the lab methodology and the instrumentation, as well as all of the routine maintenance and cleaning of the ICP-MES, which happened a lot. I'd also like to thank Scott Mazzone and the Quinault Indian Nation for providing the Dungeness crab that I could examine from the Washington coast, as well as would like to thank Courtney Hart and the Port Gamble Scollum tribe for providing the Dungeness crab that I could examine from the questions.